In 2008, the university signed an Illinois Climate Action Plan commitment to reducing greenhouse gas emissions, energy usage, and water consumption on campus. This was made as part of the university president's Climate Action Committee, long acronym type thing. Basically, university presidents across the country all signed on to different forms of climate action plans to increase the sustainability of their universities. Specifically, the university made a goal of 20% water reduction by 2015 and 40% in the future. So a lot of people think that water reduction strategies are more expensive than they can be economically beneficial, but as we see water rates continue to increase over the years, and as those rates increase, the technology to increase efficiency becomes more economically feasible. Campus has already started reducing their water, but even with that, the rising water rates mean that the overall campus expenses are very high. Across campus, over 24% of the water used is used at the cooling towers to provide air conditioning for campus buildings. So how is water consumed at cooling towers? Water goes into the cooling tower as makeup water and leaves the tower as evaporated water out of the top of the stack, or it goes down to the sewer as blow-down water. Makeup water has to be continually added into the tower to make up for all of the water that is sent out as evaporation and to account for any of the built-up concentrated water that's going to the sewer. So the concept of evaporative cooling is really familiar to everybody. It's exactly the way your body cools yourself off when you're exercising. Water leaves your body with the heat. It evaporates off. It leaves a salt residue behind on your skin. These are the very same things that you're going to see happening at the cooling towers, and this is the effect used to cool the buildings on campus. So you can there's a cycle setting for how you operate your towers, and as you increase the cycle setting, it becomes more efficient. It's like changing your gas efficiency from a Hummer to a Nissan Leaf. And along with that, just like in sweating, you have salt residue left behind as the clean water is evaporated off, and so you end up with a higher salt concentration inside the tower that must be chemically managed to prevent it from precipitating out. If you look at how the campus cooling towers are currently operating, the most efficient towers right now are about 3.5 cycles. The least efficient are just barely over 1, which means the water is nearly going in and out to the sewer. So we took a look at how all the water was being used on campus, at the cooling towers, what the chemistry was like, how they were operating, and we tried to come up with some strategies for how the water reduction could happen. So there are many different things, including control, reducing cooling load at the buildings, reuse water within specific locations, but we think the easiest strategy is just to increase the efficiency of how the tower is operating. So if we take the average cooling tower cycle, which is just over 2, and take it to the 3.5 for all of the cooling towers on campus, you could save 65 million gallons of water a year. Just flat out, very simple change in chemistry and management. These changes, incidentally, are actually very cost effective. As we increase the efficiency, like going from the Hummer to the Leaf, we actually have lower annual expenses for water. So why hasn't campus done this? Because change is hard. A lot of these different locations are isolated. There's only staffing to get to them maybe once or twice a month to make sure they're operating regularly, which makes chemical management difficult. So don't change everything at once. Take a look at the information you have, look at the high throughput users, look at places with lots of staffing already on hand, and make strategic changes. It's just like choosing to get on the bus for a while rather than making a huge capital input and making a difficult choice of going directly from a Hummer to a Leaf. If we could only change 7 towers, we would still save over 57 million gallons a year, which is a pretty significant amount of that, over 60 million. And we would have over $100,000 in savings in 1 year, which is the same as filling 87 Olympic swimming pools every year in the water saved from these cooling towers. So when we're talking about the water, it's a very significant amount of water that's being used currently. These 7 tower changes would also cause a 20% decrease in total water usage at the cooling towers and a 5% overall campus water reduction. So it's a very strategic, targeted approach to manageable locations that can cause an overall campus change. So, thank you.